Okay, shaft 2, similar component, we have dampers and we have rotating mass and we have a spring. Okay, so using the same formulas we can write. So we can say spring and we have rotational mass. So over here, spring constant K2 and theta 2. That is your fourth equation. And the next is using J2 and theta 2. Is it J or J2? J2, yeah. So this one, B square theta 2. So we have a phi equation based on phi component. Okay. So we have three component on the shaft 1, 1, 2, 3. Shaft 2 we have 1 and 2. So total 5 component, we return phi equation. Okay. Based on the phi equation, then we can try to connect all the equation in a force formula, force calculation. Okay. So maybe I just go with the first one, which is written as the shaft 1 when I rotate the torque 1. Okay, so maybe make it simple. Forget about the shaft 2. Now I'm going to use, there's a T1 is there. When I'm going to rotate, what will happen to the entire shaft? And what is the force is opposing or repelling each other. I mean, affect each other. So over here, we can simply say, even I return the other way, I'm applying torque 1. I'm going to rotate. So as per the question, what are the components is there? First is the mass, net 1, okay? Then we have a damper, D1. Then we have K1, okay, which is nothing but the spring. Then we have speed, also called gear torque, okay? So put 1. So maybe just follow here, not over there. So basically there's 3 components, okay? Then there's a gear, okay? This is N1, I put it as a gear, okay? Which is equivalent to the torque of the shaft. So is it okay? Okay? So equivalent to the first shaft. Okay, so shaft 1 connected to a gear to the shaft 2, okay? So two shaft is connected by using a spur gear or any kind of gears, which is transmit the rotational motion or torque, which is from the shaft 1 transfer over to the shaft. Okay, how much the angle is going to rotate? So that is the ultimate our relation to be found. Okay, so by having the torque shaft 1, transfer the motion over here to get the theta. Okay, so this is your sixth equation. Okay, so I'm trying to express over here. So here another line. So you have 5 component, and that's a force or torque equivalent equation. Any question on the sixth one? Yes.
Sorry, this one check what is
TN.
last
TN1 is a gear torque, this portion. So which is here, of course, they written as a 1 line. Okay, so it's nothing but the shaft is connected to the end is a gear. Then this gear 1 and gear 2 is going to be transfer the motion. Here they just represent N1. Okay, so in terms of force, we call as torque. Okay, so for the rotational motion, that's why I put it torque for the gear, N1 gear. Okay, so likewise we have a torque on second shaft also. So if you ask me, yes, it's very straightforward. 1, 2, 3. You can really see the picture, the symbols, and this one, of course, you need to see the rotational directional symbol. Only one arrow will be there. Okay. Again, the shaft 1 is 1 line, but you need to notice that is N1 specified. Or in the way, the question here they specify. N1, N2 are the total number of gears. Okay, so they specify over on question. Okay, so here they specify just a line N1. Okay, so that's the difference between linear system and rotational system. Rotational system just need to look more, whereas the linear is straightforward. Okay, and yes, sorry. So this the fourth equation, and the next last one, of course, we are going to use the shaft 2 to write it. That's the seventh equation. So shaft 2 obviously we based on our speed. I mean there's 1, 2, 3. Okay, so we have N2, we have J2 and K2. So that is based on that actually, which is simply to say now which is equivalent to the speed of the second gear. It's nothing but your net rotational mass plus spring. That's our seventh equation. Of course, this 5 equation more to the component, this 2 is more towards force or torque equation. Okay, so that's all. So one is more towards spring, this is more towards torque or force. So that's all. Every shaft, one equation. Shaft 1, one equation. Shaft 2, second equation. That's all. Equation completed. So that's the first thing we need to make it in a way like the first subdivision, find out all the system equations. So we have 7 equations, each carries at least 1 mark. Actually, this one carries 2 marks. The first equation carries 2 marks. Okay, that's how it works. Are we good? Or we have any question on the 7 equations? T2 equal to N2, yeah, okay.
So is that minus T N2
Okay, so we'll come again. So N2 equal to?
equals to, so just T2 like how you show the top one, T1.
Oh, okay, here. Okay, so very simple to understand this one. In your picture, is there any T2? Alright, so ignore that. Even very simple, this is external T1. So basically, I'm going to apply my manual force, that's my input. I'm going to rotate, so specify as a T1. If this one is not there, then I don't need to put T1 on my 6th equation. Okay, but here they specify, otherwise, then only I put it there. So for that case, I don't have a T2 over here. Okay, so it's basically N2, J2, K2, these 3 ones. Yes, questions? I mean, don't mind to ask questions because we need to understand. Of course, now is much more familiar of the system equation. Writing from the formula sheet is okay. In 1 to 5. Equally, this thing is the next thing what we are trying to understand. Okay. So ask more questions. Why and why not? So why can not be T2? Or why? Maybe I put it this way. Maybe quite radical, but it's okay. Just to ask this question. Okay, maybe put it minus instead of plus. Can it be minus? Tn2 minus K2.
No.
Is it possible? No, because it's linear. Add together. That's why it is plus. It cannot be minus. Okay? Because this component and this component attached together. So it is together you get a force on it. To oppose whatever coming on that. Okay? So we need to see the construction how it is, then whether it's addition or subtraction. Yes, you cannot add everything together in one side because it is the one driving it and this is the component opposing it. So that's why it is opposite side. Okay? Because whatever torque you are getting in, let's say it's equal to T2, very simple to say. Because that's T1 drives this one. Consider Tn2 or T2 is the same thing. This is giving these 2 components trying to resist, trying to not rotate it. Okay? It has to overcome. Then only you can be able to get that. Okay? So that's how we can make it maybe like to force equation or torque equation. So yes, the equation now completed in a way like all this equation you need to make further reduction using differential method or you can use block diagram method. Okay, so that's how it works. Of course, this is the general formula for understanding for start and versus speed and angle. Okay, I give this final answer. Your transfer function. So straight away answer is there. Like your first question, even it's simple, like one term only. But here we have like a more than 5 components or 6 components. Your final transfer function answer will be like that. Okay, so there are a big chunk of pattern of equations. But how to get it very simple? Now we trying to combine this. Now you say like block diagram method. Block diagram is simple. What is the input for this equation?
T1.
T1, okay. What is the output?
Theta 2.
Theta 2. So no matter whatever block you are making, sub blocks you are making, that is your block diagram. Okay, so then you apply A tools to reduce it to get to a final like this. Okay, so very easy to start. Okay, you need to identify what is your input, what is your output. Okay, now if you want to convert this entire equation to a block diagram, we try to fulfill all the 7 equations over here. Then it's already solved. Okay, I mean you can make your block diagram. Okay, for the start, of course, you need to write input and output. Then you try to fulfill one by one. Okay, which is say anything relevant to theta 2, then you can refer this equation. And theta 1 is, I think here it is deriving theta 1 over here because T1 is shaft 1, whereas over here theta 2 will be coming in, all the shaft 2 will be coming in. Okay, we have a sub blocks, everything to make it to complete all the 7 equations. Okay, so that's how we are deriving. It's very simple to start the block with this and some input. So this where you can start any block here. Okay, because you are going to tap, going to get something. Then only you start to get something. Then you can have your blocks. Okay, so this is how we can work out, and whatever gains we can put it accordingly. Blocks over here, multiple blocks, on here also multiple blocks to cover all the 7 equations. Copy good? T top one. Equation 3. Okay, so it's based on the mass this component. Okay, let me. Okay, so this equation T net, right? So based on this, the mass of it, where we can see acceleration or double the theta dot I. So you can say this component. You can say even not net is okay. You can put it like maybe I or even other terms Ti. So this is reflecting this component. That's why you can see J1. So J1 and acceleration, angular acceleration, that's why it's theta double dot. So that's where this component. When you ask about the second shaft, it's easier to say. Sorry. So a similar component. Instead of net, we say J, and angular acceleration is theta double dot. Okay, so that's how even you don't need to write as net, you can write as other terms, you can say I or J. I think J is better because you already have J1, J2. If you are confusing, yes, you can write on your own word, so it's say TJ2, which easily relate to the component. And this terminology, what you are writing is okay, you can go hard on it, J1, you can put it J2. So now you can relate the component, yes.
So how do you relate shaft 1 to shaft 2?
Shaft 1 and shaft 2.
Yeah.
How do you connect it?
Yeah.
Okay, that is basically on the question, which is a shaft gear system, 2 rotating shaft. They specify as a 2 rotating shaft, mean like it's very simple to understand like 1 and 2. So SA1 means all the components in the shaft 1, 2 means all the components in the shaft. Because they say on the question, 2 rotating shaft. Okay, so I'll specify 2 gears and J1, J2 for the rotary inertia, which is nothing but the mass of it, of the 2 shaft, and N1, N2 is total number of gears, K1, K2 is spring and damper. So basically it just relate by 1 and 2, and it is clearly specified as a 2 shafts. Any other questions? Of course, first trying to understand the system, how it looks like, how it constructed, then convert all the individual component into an equation. Any other questions?
So you can demonstrate how you draw the block diagram the whole time. Just the first part. We need to know the.
Okay.
Yeah.
I know it's going to be very big, but
How you
anyway.
link the first and second shaft.
Okay, so very simple. So as we know, start from T1 and θ2, right? So now we can have equation, even like which one you can able to get as differences. Okay, so you need to see from here or here, then you can go on it. So yeah, T1 is here, right? So there's a T1. Yeah, I can spot T1, and anything relevant to θ2, then we can go on it. Otherwise, we can start from one of the things, then we can go from here. So all the T1 is come over here is everything. So we have like individual things we can make it. We will start somewhere θ1, 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 this is θ2, and this is J2. Okay, so this is θ2. Okay, then θ2 again with A. Okay, so very simple. When come over here, it starts with θ2, right? So these two, okay, will be relevant to here. Okay, so which is nothing but I can make 2 blocks. I mean, temporarily I can make 2 blocks first. Okay, so this I'm going to rewrite. The fourth one I can rewrite in terms of θ2. What will get Tk divided by K2, right? Okay, Tk2 divided by K2. So you can form the equation something like that, because now, okay, so over here, this is θ2. Okay, so with the block, whatever block, the next is coming with θ2, then whereby we can get it over here. Then next, this also I'm trying to make it in a way like we can relate with J2, yes. So I try to make it this way. Again, θ2 means this will be coming over here, Tj2 divided by J2d square. Okay, so both is θ2. So it doesn't need to be in series, it can be a parallel also, right? So to get it exactly the same thing. So when you combine these two first, then we can able to make over here. So likewise, we can go every individual rearrange, then make individual blocks on it, then finally is connected. And sometimes it is doesn't really need to be a feedback. It can be on top to connect also. It can be made this way also. Okay, so that's how we can make every equation. So over here, very simple. Apart from system equation, you can add in. All is addition, right? So very simple. Where in your block diagram get addition? How to make it the addition? Because this is just multiplication, right?
Root 2 parallel.
Parallel. So the block is parallel. So that is another way to write. When I get it is so likewise. So because as long as everything in class, you can able to fulfill everything. Okay, so if you say minus, you can put minus. Otherwise, everything is going to be plus. All the symbols will be plus on it. So which is simply to say J1, yes, and B1, K1, and N1. So that's how we can relate. So you can think of parallel, series, or even feedback. So that's why we know from our block diagrams. Of course, there will be further questions. Even I don't know whether I can have the examples. Let me see. Okay, this is a differential equation method. Yes, I think. Yeah, this is a block diagram. Okay. Yeah, this is how we can make it. You need to draw one by one to complete. Maybe we'll go through this question so that it will be easier to say like output and input. You try to make it individual blocks and summing internal or external to find relatedness. So at the end of the day, all these equations will be here. Okay, maybe I think we'll go through this one, this as a complete one actually.
So
Yes.
So you don't need any equation to link shaft 1 to shaft 2. To draw the block.
Yes, for here, I don't think so. So you no need to have a feedback. Okay, so of course depends on the equation. Our first example, yes, it is connected. Then we have feedback to connect it. Otherwise, it will be enter like one way, forward path only. Then it will be all individual blocks of meters. So this one, I believe there is some takeover. That's why they are connected with the two systems because it's all interlinked. Because linear system is all interlinked in one thing. Whereas the rotational two individual shafts. So whereas this system all is connected in one system. Whatever effect, everything is bind together. Okay. The rotational systems slightly differ. Maybe like even it can be entirely forward path. No need to be linked back unless the component is arranged that way. Okay, good. Any other questions? Okay, maybe I'll go through other examples so that we can have full block diagram. Okay, when we start over here, this one is translation. One of the exam question. Okay, 2019 year exam question. That's why we can. Okay, so this equation, of course, we have a linear system. So basically, we have one spring, damper, mass, and another spring. So it's like a 4 component, and we have like a system equation, transfer function, time constant, and gain constant. Whereas the external force F is taken as an input, okay, and displacement taken as an output. So we need to read the question to understand what is input, what is output. Then we can get the transfer function. Output versus input is nothing but x2 divided by force. That you get the equation over here. Okay, so to find what is the time constant, what is the gain constant. Okay, so this is using equation method because the question is say like transfer function using equation, not block diagram. Okay, so maybe just explore the equation first. Of course, deriving from the formula sheet, these 3 components, and we can able to get the formulas. Okay, so over here. So here we have 6 equations, and component 1, 2, 3, 4. Okay, so there's a 4 component written 4 equation. Then 5th and 6th is more towards the force equating. Okay, so come to the first component, which is nothing but the spring. Okay, this is the first one. K1 is nothing but K1 and X1. So that is where the first equation. So are we good on the first equation? Okay. Second one, more on damper. Okay, so it's nothing but C, and we have differences. Like delta X velocity. So X dot. Okay. Here is X1 minus X2. That's why I put and capital letter D. I don't want to put dot, so that's why I put D. So X2 minus X1. And third component is second spring K2, which is the difference between the two distance. It's nothing but X2 minus X1. Whereas the fourth component is the mass into X double dot X1. So instead of double dot, we can put this one. So is there any question on the 4 equations at this moment? We will go with the questions. So 4 equations based on the component, and next is when the force is applied, okay, nothing but external force is applied, what will happen to the X1? So that is our question. The force is specified by the spring and the damper. That's what the 5th equation trying to reflect. I mean, like the applied force is equilibrium with the spring and the damper. Okay, that's what the 5th equation is trying to indicate. And the last equation, which is the bottom part of it, is nothing but the entire force. Okay, there's a K1, yes, there's a mass. That's where you can see at one side of it. Your mass and spring is equivalent to the spring as well as the damper is opposing. Okay, it's trying to things which is equivalent to one of the car or train system. Okay, so there will be one more damper is added, meaning that is equivalent to the train. Okay, so over here this force is equivalent to that. So that's how we can make it as a 6th equation. Are we good on 5th and 6th force equation? Okay, so if no question, then of course this is using equation method, rearranging the equation, then you can able to come up with the transfer function. How to make it? Very simple. We try to, let's say there's a 4 equations over here which is based on the components. Okay, then 5th and 6th is more towards force. Try to substitute all the equation what we get it to the main 4th equation. So actually the 4th equation is the one we are have to make it to solve it. Okay, so we have K2, yes, we have a K2 formula. C, yes, we have a second equation, and here K1 as a first equation, and force of mass 4th equation. It means like every individual terms is a relevant equation value is there, you need to substitute that. Okay, so that's where the questions comes
So
in.
the
Yes.
small f is also equal to the spring force and the mass, the force of the mass. Fk1 plus F.
Sorry, come again. Yep.
The small f, right?
Small, yeah, force, yeah.
You can't totally ignore the spring and the K2 and the dampener.
Yes.
And it's also equal to the mass, the force of the mass and the force of the K1, right?
Yes, correct. I mean, force is equal to K2 versus C.
Okay, but it's also equal to K1 plus Fk1 plus Fm, right?
Yes, correct. Because it is relating whatever we are getting compensating by these 2 components, which is exactly opposite to the K1 and the mass. So that's why you are getting. So end of the day, the system what we are trying to make it is an equilibrium, trying to make it stable. Okay, so whatever the shock absorbing, basically it is happening an external force. I mean, applying external force, this is going to be momentary force, but the component like spring or damper trying to nullify after some time. Okay, based on the time factor, that's what time constant is there. So when you say equilibrium to become nullify that, obviously we need to see what are the component, what is the constant on the rest. Yes, questions further? Okay, so based on force equation, we substitute all the values over here. What I written over here, equation 1, 2, 3, 4. There is nothing but the component. Okay, component values you substitute to the equation 6. Okay, so it's nothing but this your equation 6. So basically we are substituting K2 means that's the value of it. Damper, then we have another value, force of mass with another symbol which is from equation 3, then equation 4. So we are taking all the values, all the equation to the main 6th equation. Okay, so substitute it, then multiply and rearrange. Okay, so by means we can have a common factor on it. So which is I derive until to the final reduction and make it like a 7th equation. Try to make it as a equation numbers continuously so that you can track back actually. Maybe just you want to go through it, or is it understandable? Like a very detailed one is nothing but, okay, simple to say. So we take every terms, then equation submitted. Okay, then you multiply K2 to the bracket, so I get K2 H2, or K2 x1. So we expanded the equation. First term is like this. Then second term CD x2, CD x1. Okay, so that's the second term. And over here remains as it is. Okay. Then you can connect all the x2 and x1. Very simple to say. So here x2 is over here, and this term I can pull to the other side. Okay, because x1 I can pull to the other side, and x2 remains over here, and then we can see this again x1 and go to the other side. So it ends the way. So CD x1 and K2 x1 will be coming on this side, and these two terms also coming over here. Okay, are we good? Basically, one side you can see all the x2, the other side you can see all the x1. Then we take it as a common factor, the x2, take it out. Then you have K2, CD. Okay, so that's where this your right hand side will be there. Left hand side, right hand side, we can say all the x1. Common term is x1. Take it out all the x1. So we have CD. Okay, CD here, K2, K1, and MD square. So one side is x2, the other side is x1. Yeah. So then we try to create x1 is nothing but this entire term will be coming down this side. It's a denominator divide. So it's nothing but x1 equal to x2 multiply this term. The numerator remains as it is, and this is going to be our denominator. Okay, so that's how the last steps is coming. Questions on from here, these three steps. Trying to rearrange in terms of x2 and x1, then make a final relation. X1 is nothing but something. So because why I'm trying to relate x1, because that is the force versus x1. Okay, transfer function is based on force versus x1. So we are trying to relate. So x2. So later we can rearrange the equation to make it. Over here we have a fifth equation. Okay, so one more step now. We are running the sixth equation. Then next is fifth equation. Sum it and trying to make it the final equation over here. Whatever solve, we can able to make it solve. And finally we get x1, right? Instead of x1, now I'm going to substitute this entire term. What we get it as a seventh equation. Okay, then you substitute on that x1. Then if you look on our entire equation, there's only two terms. One is f, another one is x2. So rest all will be eliminated. Okay. And it is going to be extended. You can able to rearrange. Maybe you can take your time to look on the further expansion of it. Then we can able to solve in terms of ratio x2 divided by f. So that's where you can rearrange and substitute all the numbers. Let's say now they're given the values like a m, so-called C, K1, K2. So as per the question given. Otherwise, it is going to be stuck over here itself. Okay. If the question given any mass value, damper value, stiffness, then you can substitute all the numbers over here. Then it is make it much more easier to reduce it. So basically substitute all the numbers, then solve it, and trying to make it this value is 1. Then on the denominator and numerator, then we can get it further reduction. So when you see a further reduction, then it will be end up like this way. So this is a higher order system in like d square, d cube, you can able to see. Okay. So what is the time constant can be considered? Okay. So now we can say 7 by 10, that is your gain constant. And whichever relevant to the d, then it is considered one of the time constant. Let's say now start like from numerator, d square, then this is called t1. And again there is one more d, it is called t2. And here is T3, T4, T5. So we can able to number accordingly, then put all the time cost. Okay. So that's how we can rearrange the equation, then we'll get all the time constant or gain constant. So are we good? There's only one factor is okay, great. Maybe I need to move it on. Actually, it's from our last step. Yeah, that's a formula for the transfer function for higher order. Our first order we are very familiar, which is nothing but 1 plus TD for first order system.
So can you go back to the previous slide?
Previous slide, okay. You want one more? Okay, this is already in the ratio. And simplify and substitute the numbers. If the number is not given, we can stop over here. It's over here, it's finished already. So now the number values is given like mass, dampers, then you substitute, you can try to simplify.
Okay, go back one more slide.
One more slide, okay. Yes, question? Okay, basically now the first one equation, okay, so basically all the 4 equations, we have 5th and 6th. So you substitute 6th equation first and try to solve as much as possible. Then the same thing for 5th also. We have a K2 and C. So 3rd equation and 2nd equation. These 2 equations, you need to substitute. K2 is nothing but this one. And FC is nothing but this one. Okay, so I'll come back to that. This we already know it, yes. We have K2 substituted and FC we have substituted. Again rearrange to become like a term like F equal to something. X1 from our 7th equation, we can substitute X1. Then it's the term for the thing whether F or X2. So no other terms will be there. And we can rearrange and write it up. Then we can proceed to further apply the value on it. Questions? This is our 5th equation. Okay. Then we have 6th equation. Sorry, 6th equation we already done. 5th and done. So combined, that is the transfer function for the higher order system. Where you can see numerator we have d square and d cube. So it is going numerator and then it follows with denominator. Okay. Wherever you can see d, then you can say that is our time transfer. Because it's going to be longer things. We're using an equation method. And the next one I'm going to run is a block diagram method, which is much more detailed on this. Question from here or from previous slides? Okay. We need to move on. So basically, overall, the example 3, we have 6 equations. That's your answer. And the B answer is nothing but your transfer function, which is come over here. This is your transfer function. Okay, so which is nothing but your gain constant and arrangement of all the time constants. Okay, and on the C part, just writing down from this over all the things. It's nothing but we have a gain constant and 6 time constant. So that's a C part. So the answer for these higher order systems, that's how we evaluate on it. Are we good? Or we have any question? So this is your very first things in a way like the question. System equation, transfer function, and time constant and gain constant. That's a ABC, which is given over here. Okay, so that's our answer. Probably we will be going with the next question with block diagram, which is like something the same equation, but trying to build the block diagram. I think the block diagram is going to be more adventurous because there are multiple blocks will be there. But yeah, we'll go for a break about 4:15. Then we will connect and we will go on to exercise 4. Okay.